Okay, today's lesson didn't get recorded, so I'm repeating it here for those of you that couldn't attend. Basically, all we did was look at 4 different examples from the Kahoot that we asked you to complete the other day, and we tried to figure out which one used the sine rule and which one used the cosine rule. So I can probably get all 4 on the screen here and make it small enough. And what I'd like you to do is just take a minute or so, not more than a minute, look at each of the 4 different examples from the Kahoot and make a decision if it's a sine rule or a cosine rule that you would need to solve for the missing quantity x. Okay, I'll give you a minute or so to do that. So maybe push pause on the video and do that, and then we'll be back in a second. Okay, so if you chose those rules, we can take a look now and see what you come up with. The first one here, if we're trying to find x, this should be the sine rule. Okay, and the reason you know it's a sine rule is you've got an angle and a side that's opposite to it, and an angle and a side that's opposite to it. So if you set up the sine rule, it'll go 6 over sine 35 is 8, whoops, 8, I don't know, that made a circle, 8 over the sine of x. And then from here, we can solve for sine x. If we cross multiply, you'll get, let me make this a bit bigger here, you'll get 6 sine x is 8 sine 35. So if we keep working on that, we'll get sine x is 8 sine 35 divided by 6. Okay, now if we take out our calculator here, we can get this come onto the screen there. We need to figure out that number. So it's 8 sine 35 divided by 6. That's the number there. And then we'll take the inverse sine of that number, and that'll give us this number here, right? So the sine inverse of 8 sine 35 over 6 ends up being 49.9 degrees. Okay, and if you look at the diagram, that makes sense. That's about a 49 or 50 degree angle. But when you're doing inverse sine, you should always think about the cast rule and the fact that, you know, the angle whose sine is equal to, this number here was 0.7647, and some more stuff, could either be in the first quadrant or the second quadrant. So sure, it could have been 49.9, but it could also have been 180 minus 49.9, which is 130.1. However, if you look back at the diagram, clearly we want the acute angle. There's no obtuse angle there. And so the answer is 49.9. But you should always give it a moment's thought and make sure that the angle that you're getting, the acute angle that you're getting, is the one that is required by the question. Okay. Now the next one is a similar one, in fact, I'm going to change that. I'm going to put, oh, well, not the heck, we'll just leave it the same way. That way it'll go with what you were thinking before. And you were probably thinking here also, hopefully you were thinking here also, the sine rule. And once again, we're looking at a complete ratio here in the sine rule, because we have an angle of 51 degrees and the opposite sine 7. And over here we've got an angle x that we're looking for, but we have the opposite side 9. So let's go back to blue here, and we can complete that one over here. We set it all up. We'll get 7 over sine 51 is 9 over sine x. And so if we cross multiply that again, we'll get 7 sine x is 9 sine 51. And so if we keep working on that by solving for the sine, we'll get the sine of x is 9 sine 51 over 7. And once again, oh geez, what happened here? There, don't know how I did that. And we'll go back to here. So if we do 9 sine 51 divided by 7, that number, oh, it's about 0.99187. And then if we do the inverse sine of that number, you see we're going to get that x is the sine inverse 0.99187, which is 87.7 degrees. Looking at the diagram, that's what they want. That's an acute angle. And it's not 90 degrees. 90 degrees would be a little bit bigger, be something like this here, if this is perpendicular. So that's the right angle. We don't have to worry about the obtuse angle. Okay? Now, Kahoot number 10, here you were given 3 sides and you're looking for the angle. So hopefully you guys said that was the cosine law, and that will work because the cosine law, if we go back, you see the cosine law, if you have all the sides, all those there, and you're looking for angle A, you can solve for angle A. The only thing is, if we want to look for angle A, we have to make sure we have side A, and in this question, nothing's labeled, right? So if you want to call this A, to make things easy, that will help you identify that the little a would be the side opposite the angle A. So the version of the cosine rule that we want to use would be something like 5 squared if 4 squared plus a squared, 8 squared. I mean, you can call these B and C any way you want. It doesn't matter. They're just going to be squared and added together on the right-hand side of the cosine law. And so they have the same effect. And then you continue on and they just get multiplied. So it doesn't matter if it's 4 times 8 or 8 times 4, that's the same thing. And this would be cos of x. Okay, and to solve this, we have to work out these numbers. This is 25, 16, and 64. And then this is also 64 cos x. Okay, now we add these two numbers together, but we don't subtract it from the 64 here because the order of operations means that we'd have to multiply by the cos x first. So what we do is, whoops, erase that. What we do is we bring the 16 and the 64 to the other side. And that'll give us 25 minus 16 minus 64 is a minus 55. Okay, and then now we'll divide both sides by 64, and we'll get minus 55 over a negative 64 is cosine of x. So we could just do 55 divided by 64 because the two negatives cancel out. And that gives us that the cosine of x is 0.859375. So we undo the cosine by inverse cosine. And that tells us that x is 30.75 or 30.8 degrees. Okay, now, do we have to worry about the obtuse angle? Well, in this case with the cosine, the answer is no. And the reason is, if you think about the CAST rule, all the ratios are positive in the first quadrant, but if this angle were to have been in the second quadrant, then the cosine, whoops, the sine is positive here, c's down there and t's here. Sine's positive, but cosine is less than 0. So if we were meant to get the obtuse angle, that would mean that this ratio here should have been negative, but since it was positive, that guarantees that the angle should be in the first quadrant. So we don't have to do the same sort of considerations that we did up here for the sine because there's no ambiguity about the cosine. When it's positive, you've got an acute angle. If the cosine ratio is negative, then it would be an obtuse angle. Okay? All right, we're just about done. One last question here. This one now, what we have is 2 sides and an angle, okay? But the angle is contained by the other 2 sides, and we're looking for the x. And I hope you said cosine rule, because that's the one that will work. So if we have the cosine rule, okay, we can set it up by like looking at this as say A, and this is little a, and these could be B and C, it wouldn't matter. And then you can see that if we had BC an angle A, this top version of the cosine law would solve for a squared. So if we write this one, we have x squared is equal to 7 squared plus 6 squared minus 2 times 7 times 6 cos 64. And this is kind of the basic example that we started with the cosine rule the other day. So we're going to just evaluate everything here on this side of the equation using our calculator. So 7 squared plus 6 squared minus 2 times 7 times 6 cos 64. And that'll give us this number here, 48.176823, et cetera, et cetera. And that's really big. That's because we still have to take the square root of that number to get the result. So x is 6.94, so one decimal place 6.9. And looking at the diagram, that's a reasonable answer. Okay, so if we back up, let's just get the calculator out here for a sec. If we back up and look at these 4 different examples, we can kind of classify them based on the information that we're given. We go backwards, the one that we just did, we have 2 sides. Okay, so we have this side here and this side here, and in between we've got this contained angle. So we call this version SAS. If we have SAS, that's the cosine rule. Okay, now over here, if we look, we've got all 3 sides. Okay, so we've got a side here, and a side right along this side here. So not surprisingly, we'll call that SSS. SSS and SAS, it is the cosine law. Okay, now above, actually, these are 2 of the same cases. What we've got is 2 sides. We got this side, and we got this side. We've got this contained angle. But notice the angle, uncontained angle, not a contained angle, but an uncontained angle. Notice the angle isn't contained. Here would be contained. Since it's not, we're going to call this one SSA. Okay? And when we have SSA, that's the sine rule. Okay? And this one over here is exactly the same. So you've got side, and an angle that's not contained. Okay? There's one more case that we didn't find an example of. I can just draw it down here. Okay? And that would be if I had triangle and I had an angle. So maybe this is 30 degrees and this one is 65 degrees. So an angle, and then I have one side length. Maybe this is 5 centimeters, and I'm looking for this side. Okay. Once again, you can see we have an angle opposite a side that's given, and we're looking for another angle that's opposite the other side. So this will work with the sine law. Okay, if you set it up, you'll get what? 5 divided by the sine of 30 is x over sine 65, and we can solve for x. Okay, in this case, since we're given 2 angles and a side, we call it angle, side. Okay, so side, angle, side's the cosine law, but side, angle, and angle, side is the sine law. That's pretty much it. Okay, so tonight for homework, what I've put on for the Google Classroom are a mix of questions with the sine law and the cosine law, and hopefully what we did today will help you sort out when to use which law. So I'm going to stop sharing the screen here, and I'm going to wish you good luck on the homework. Any problems with the homework, you post them on the homework help, and we have a meeting again on Friday, and in our Friday meeting, we'll take those up, and we'll try and pull everything together this week. You've looked at the sine law last week and the cosine law this week, so Friday will be a good day to put everything together. Okay, best of luck. Bye-bye.